Hello, everyone, and welcome to today's exciting webinar. I am Tim Stark and your host for today's webinar, which is part of an ongoing series of emerging topics in geosynthetics. Today's webinar is co-sponsored by the Fabricated Geomembrane Institute, which is an industry-based organization at the University of Illinois at Urbana-Champaign that promotes the use of fabricated geomembranes and other geosynthetics for a variety of applications through its research, education, and technology transfer activities. Today's webinar is also co-sponsored by the North American chapter of the International Geosynthetics Society, or IGS-NA. I am currently a vice president of the IGS-NA and pleased that the IGS-NA is also sponsoring our free webinar series. IGS-NA's mission is to educate the civil engineering industry about geosynthetics via webinars, educate the educators course, student and professional memberships, and conducting geosynthetics related conferences and workshops. During today's webinar, we welcome questions and comments which can be typed into the question box in the control panel. You may send in your questions at any time during the presentation, and we will address them at the end of today's presentation. The recording of this webinar and a PDF of all the slides will be made available on the FGI website after today's presentation. PDH certificates will be sent automatically to all who attend the entire webinar. So today's webinar speaker is Elliot Pugh of Wind Defender LLC, who is giving his webinar from Pottsville, Pennsylvania. Elliot Pugh received his bachelor's degree in civil engineering from Widener University near Philadelphia and began working as a project manager and estimator for a general contractor focused on landfill construction. Elliot has spent the last 7 years of experience in the landfill industry and is currently the sales manager for Wind Defender LLC, a geosynthetics company focused on exposed geomembrane cover systems. It is great Elliot squeezed us into his busy schedule to give our September 2019 webinar titled Temporary Landfill Covers, Design, and Construction. Please welcome Elliot Pugh.
Thank you, Tim. Thank you, Jen. Thank you, FGI. I appreciate you guys having me on today to do this talk. As Tim said, I'm going to cover temporary landfill covers, design, and construction. Maybe a little bit more background on myself. After completing my engineering degree, as I went to work for the earthwork contractor specializing in landfill construction, I really got involved in all the different facets of the landfill industry, from lining materials to earthwork to piping to horizontal collection and gas wells. So it really gave me a nice broad knowledge of the industry and how these projects are, built, and the coordination between general contractors and installation contractors and fabrication companies all together to make successful projects. So today I'm really going to focus on ballast systems and exposed geomembrane cover systems. With the exposed cover systems, it's definitely a trend in the industry. We're seeing more and more of these exposed membranes. I'm going to cover the different applications they're used in, kind of how you should go about deciding which product fits each application best, and also touch on some prefabrication. And then, of course, we're going to cover some ballast systems, some of the traditional methods out there, what options you have, and some of the challenges faced with those products and systems. So first off, the three applications you're going to primarily see where exposed membranes are used are cell rain covers, temporary or interim caps, and stockpile covers. I know most of you are in the industry and familiar with these, but I'll touch quickly on some of the major benefits. First off, cell rain covers. It's pretty self-explanatory. Whenever you're building a new landfill cell, once the construction of that landfill cell is complete, a thin mill membrane could be used to cover the protective cover soil layer. Essentially what that thin membrane is doing is segregating any stormwater from leachate. So we all know the second we put any trash in a landfill cell, and any stormwater or precipitation that comes in contact with that trash needs to be treated as leachate. These cell rain covers are very effective at separating those two solutions, leachate from stormwater. In addition to that, you also have benefits of erosion control to the underlying protective cover soil layer. These membranes and ballast systems can be used to protect any underlying geosynthetics from UV damage, as well as improving the runoff quality. So just quickly, the photo you're looking at there is from a power facility. There were about 500-foot long slopes and very steep, 2 to 1. Quickly, the contractor realized as they were pushing their protective cover soil layer up the slopes, they would have some washouts, and we're constantly battling keeping that protective cover on the steep slope. They needed a way to protect the underlying geocomposite, so prefabricated thin mill reinforced membrane was used as a means for UV protection to the geocomposite, and then a windscreen ballast system was placed over top to provide the ballast on that cover. Quickly, one of the calculations we do just to see if a rain cover is feasible for your application, it's pretty simple math. You could take a 10-acre open lined area, do the calculations to determine how many gallons of leachate you would collect annually, and you can input an average disposal cost of 12 cents per gallon when you're analyzing this, and essentially you're coming out with about $1.7 million in annual leachate treatment costs. Now, obviously, treatment costs vary from site to site if you have direct hookup to sewer or if you're trucking your solutions off site. So really, I've seen disposal costs anywhere from a penny a gallon upwards to 30 cents a gallon. But if you were to install a 10-acre rain cover, supplied and installed rain cover and ballast system, you're looking in the ballpark of $200,000 to $300,000. The second common application for these exposed membranes would be temporary covers, or interim caps as they call them. Really, with these exposed cover systems, you're getting the same benefits as a final closure system. You're just doing it at a fraction of the cost, and you're eliminating much of the maintenance associated with a traditional final closure, or I should even say a traditional interim cap. By eliminating the soil cover, you're not dealing with erosion issues, having to worry about establishing vegetation, cutting your grass, and just the continual upkeep with that. You're also eliminating the generation of leachate, or greatly reducing it, by installing these membrane and ballast systems over top of a waste mass. It's a great way to buy your site some time if you're trying to procure funds for a final closure system. We've seen that technique implemented on different projects. And at the end of the day, you're still controlling odors, and depending on your site specific area, directly behind this installation to the right side of the photo is a housing development. So odors, visibility, aesthetics was a really big factor when it came to installing this temporary cover. And lastly, your stockpiled materials. Right here, you're looking at a photo of a clay stockpile. This site in particular started sourcing some clay years ago, and brought in a fair amount of clay to be used in the bottom of every one of their cells for the next couple of years. So they needed a way to protect that stockpile. Obviously, membrane cover was used, as well as the windscreen ballast system in this photo. So all of these applications are becoming more and more common, and they all are in line to use a fabricated membrane. they're all great candidates. And with the fabrication technology that's available, they offer a lot of benefits to the site, the installation contractor, the engineer, and really it's due to the way these fabricated panels are put together. You know, they're put together in a controlled environment indoors. They're free from dust and dirt, you know, water, wind, all the factors that you would see in the field and battle as an installation contractor. Essentially what happens is these rolls are welded together in a controlled environment. They're accordion folded, and then they were basically placed on a master roll or a large roll, and wound up, and that will be shipped to your job site. It can be put into the exact position where it needs to be unrolled and unfolded right into the area. So exact fit panels definitely cut down a lot on installation time and field seaming. Some of the common membranes you would see in a fabricated format would be your reinforced polyethylenes and polypropylenes. Really, the reason for that reinforcement and what makes it so effective, not only is it increasing the puncture and tear resistance of your membrane, but it also helps to provide a longer service life and reduce the thermal expansion and contraction of the membrane itself. So for any of you that have been out on a site and saw traditional HDPE membrane, it has a tendency to wrinkle and expand and contract due to the temperature changes because of its high thermal expansion coefficient. What happens when you're seeing this on your landfills is these piping areas, or these areas of wrinkles and folds, basically can act as piping networks. It serves as a channel for any fluids to flow through. So you're going to get a lot of tunneling of the soil underneath your membrane, or water running between your layers of geosynthetics. With the expansion and contraction of your traditional HDPE membranes, you know, you're also putting a lot of stress on areas of anchor trenches, seams, any areas of grade change or swales. You know, the liner has the ability to move, and it can put a lot of stress on above ground wells, for example. So just things to keep in mind when you're looking at the potential for prefabricated panels. So all these temporary or exposed covers are, you know, offer many benefits to your site and your clients. It's also one of the most dangerous installations to ballast. Not only is this rain cover, you know, a very expensive thing to put down, or exposed membrane a very expensive thing to install, but you need to protect that investment. So you can see in the photo attached, you know, this is your traditional rope and sandbag system. You can see the line of sandbags. This membrane, you know, was just tore just due to wind over time. I think it's really important to understand what are the two effects that are causing this wind damage to the exposed membranes. Essentially, you can break it up into two areas: crosswinds and wind uplift or negative pressure. Crosswind is, much as it sounds, wind blows across an area of an installed membrane, and these small areas of trapped air underneath the liner are migrated into one general area, basically causing the membrane to balloon and waiting for a strong enough gust to come and cause it to fail. The second is wind uplift or negative pressure. So many people think, or many folks think, that their liner system is damaged or tears because the wind gets underneath the membrane. That's not typically the case. In most installations, your membrane is anchor trenched around the entire perimeter of the installation. So there's no area for air to get underneath your membrane. What you're actually seeing happen is the flow of air, typically in areas of grade changes. So on the slope, towards the top of the slope, you'll experience in this negative pressure or suction effect, just created by the aerodynamics and the way the wind flows across the slope. So that's really what you're seeing. And over time, that constant wind whip will just weaken your material, eventually creating a hole, and then you have a problem. So over the years, we've combated this uplift effect in many different ways. Probably your most traditional method is your rope and sandbag system. This is an example on the top left corner of a cell rain cover, a thin mill geomembrane installed. And there's no rope lines between these sandbags because they're on the flat floor, but on your slopes, you'll see there's some rope lines which actually suspend those sandbags in place. As you can imagine, over time, your rope lines tend to degrade, sandbags get pecked apart by birds, and there's a lot of labor that goes into hand filling those sandbags and placing them out in the field. So just a tedious process. It's effective, but over time, typically in a 3-year period, we're seeing some type of sandbag replacement, rope line replacement, or some type of repair. You have other options such as tires, soil windrows, and ground anchors. Not every site has tires available. Definitely an option, again, that's going to take a lot of manpower to install. And the soil windrows might not be the best idea to have to get out on top of your lining system to place some soil to ballast it. And for those of you who are not familiar with the ground anchors, essentially what it is like a concrete anchor that you would drive through your lining system into the soil or into the waste below. And then a load plate is placed on top of the rod and tensioned into place. Over top of that top patch, you would have, over top of the anchor, you actually have to install a patch. So you're going to take some grinding and some extrusion welding. And this is typically done, anywhere from 10 to 20 foot on center across your installation. Just another photo here of your rope and sandbag system. As I said, with the snow loading and UV degradation, typically a lot of failures are occurring on the sloped areas. So you can see where rope lines have snapped. Essentially what's happening is the snow is building up on those sandbags and just creating more and more weight over time until your system fails. That's when you're left with the picture on the right of the failed lining system. Just a lot of work to come back in there, remove your sandbags, try and replace them, and repair the lining system. Another thing to note is with windscreen ballast systems, typical roll sizes, weight of a roll would be around 325 pounds and can cover approximately 6,500 square feet. If you were to cover that same area with your rope and sandbag system, assuming a 5x10 grid, you're roughly looking at about 4,000 pounds worth of sand that has to be shoveled into the bags, carried out, and placed on site. So safety is another a big concern with your ballast system installation. So the traditional methods that we covered so far, they all use the same concept. Essentially, put enough weight on your liner system and it'll hold it down. So you can see the photo to the left. It's the most sandbags I've ever seen installed on any exposed membrane in the past 7 years. And to the right, you'll see a windscreen ballast system. So unlike the traditional methods, the way the windscreen systems function is by aerodynamically diffusing that uplift force. So the porous nature of the knitted windscreen ballast systems allows it to diffuse and counteract that uplift force. So this next slide will be of a short video just showing again the effects and the process of this wind uplift. So the main flow of air comes across the top of your slope and creates that suction effect, which is typically greatest towards the top of the slope. You can see it recirculates the air, and as that air feeds back into the main flow, that's the area of the greatest negative pressure or uplift. So when wind defender is installed, that uplift is still being drawn out of the window. Air is being drawn up and out of the wind defender and from the membrane, and it's being replaced by a downward force of air. So essentially canceling out the uplift force. With the windscreen systems, It's typical to implement some type of quality assurance measures. So third-party testing is done on every lot of material. In addition to third-party testing, long-term UV testing has been conducted on the system, which shows a half-life of 55 years and an expected service life of 90 years. In addition to the long-term UV testing, dynamic wind testing was done up to 110 miles an hour, showing no damage to the windscreen system and still a 75% reduction in the geomembrane uplift. As we were speaking with some other engineers on a few projects, we've had some perimeter basins that were designed on a few projects that engineers felt they over-designed. They had some 100-year storm events and didn't reach the capacity of the flow in those channels. So they asked us to run some runoff testing. So we did some runoff rate testing and found that the windscreen system actually has a Manning's coefficient of 0.029, similar to the Manning's coefficient for grass. So you can understand that the windscreen systems do tend to slow the flow of the water. The material itself is a knitted UV stabilized HDPE textile. So the filaments are HDPE, they're put on a loom and they're knitted together. As you can see in the photos on the right, the windscreen system is traditionally green in appearance. Recently, we have updated kind of the color of the system. So if you can see here, I'm going to hold up a little sample. This is a combination of tan and green filament in the current system. And one thing to note is the material is reversible, so it can be installed with either side facing up. One thing to remember and pay attention to is you will see a color difference between the two sides. So we call this side our tan side to the windscreen, and this would be our green side. I'll show some pictures later, which will show you that color difference, but the material can be installed either side facing up. Just like your lining systems, the rolls are shipped to your job site. They're in roll form, 10 feet long and 1.5 feet in diameter, weighing approximately 325 pounds per roll. That roll material is C-folded, so you would unroll the roll and open it up, forming a panel 328 feet in length by 20 feet in width. All those panels are sewn together, so when your installation contractor starts the install, he'll deploy about 2 or 3 panels at a time. Sew using your handheld sewing machine, a prayer seam in the material, and then they will actually hand tension the system into place. You'll continue on with that process, 2 to 3 panels at a time, and consistently work all of the slack out of the material through your installation. One thing I think that's often overlooked a lot with geosynthetics in general, when it comes to sewing materials together, is the type of thread that we're specifying or requiring the installation contractors to use. So for the windscreen systems, we recommend a 277 polyester bonded thread. It's just a little bit thicker than your traditional thread you would use to sew a geotextile together, which is a 207. This just helps with the durability and the service life of the thread. For installations that are going to be out exposed for greater than 7 years, I would say we'd recommend a PTFE thread, which is one of the few threads we found that actually provides a lifetime warranty. It's used a lot in the awning and marine industries for really long-term exposed applications. It does come out with a higher price tag, approximately 5 to 6 times the price of your traditional polyester thread. When installing the windscreen systems, I like to put this ballast system detail on the top right. I've finished a few of these presentations and have been asked the question, how does your windscreen system stop infiltration of water? So again, the windscreen system goes on top of your membrane is on top of your subgrade. The windscreen system's acting as the ballast system. When you're making that prayer seam on site, it's important to have efficient or sufficient overlap. So we like to see at least 3 inches of material above your thread line. When you don't get the 3 inches in overlap, sometimes you will see some seam separation due to that insufficient overlap. When terminating the windscreen systems, wherever possible, we'd always recommend putting it in an anchor trench. A 2 foot by 2 foot anchor trench directly on top of the membrane. Both products can go in the same anchor trench. That's always not available, so it's site specific. Certain areas would require different means for terminating the windscreen. So in the top right, you can see a TOA slope termination, where essentially what we've done is encapsulated a continuous row of sandbags inside the wind defender material. That system can be installed using pipes, chains, grout-filled HDPE pipe. We've had a lot of different products used and encapsulated in the windscreen systems, so you can kind of be creative with how to terminate. So here's a short video showing the windscreen system installed over a traditional 40 mil LLDPE membrane. You can see it's pretty still on that side. The camera is going to pan to the opposite side of the slope, where you're going to see a 40 mil LLDPE exposed with no ballast system. So just kind of give you an idea of the effects of the wind uplift. That liner is approximately 3 to 4 feet off of the subgrade at that point in time. You know, and if that ever does fail, it can cause some serious damage, not only to the people that are out there on the site, but any property surrounding the area. In addition to its function, the system can be reused in certain applications. So you can see here is just a short video of an installation contractor getting pretty creative and installed a auger attachment on the front of a skid steer, utilizing a piece of PVC as a core pipe. They're able to take 3 panels in width of the wind defender at one time. So you're having 60 feet wide of material, which can be folded in on each other and then rolled up. That's the finished, re-rolled, reused material. So just a couple site photos I wanted to share and some kind of project highlights. Right here is one of the earliest installations of a windscreen system. Was first installed using a traditional rope and sandbag. This is a 12 mil woven coated membrane, and you can see that essentially the top half of this installation was blown off in the wind. What happened was your rope lines degraded and slid down the slope, leaving the top half of this installation exposed. So the repair was done to the membrane and the windscreen system was installed over top. This is an aerial that shows 2 separate 7-acre installations, 40 mil on each side, but kind of a unique facility in Kentucky. This site was essentially trying to procure funds in order to do a final closure. They didn't have the money at the time to import all of the soil needed for the full 14-acre closure. So what they did was in 2014 installed the first 7 acres of 40 mil utilizing a rope and sandbag system. And then in 2015 came back and installed the second 7 acres of 40 mil along with our windscreen system. Basically what this did was it bought the site 2 years to procure the funds necessary to import all the soil for the final closure system. This was that facility, those last few photos where you saw the windscreen being reused. This site actually took the material off and shipped it to another job site where the material was reused. As I said, so we had this a standard green color. This is our tan green version of the windscreen system. Just another cell rain cover application, very steep slopes, issues with pushing protective cover up the slope and getting it to stay and not erode. A lot of the erosion, this is a installation in California, lot of the erosion is caused by wind. So another means for protecting the underlying geocomposite and wind erosion. This is a 300,000 square foot installation over top of a 40 mil. It's kind of a neat application. This would be an area where a leachate evaporation system would be installed. So essentially this was a spray curtain to control any overspray from the leachate evaporation system. So whatever didn't evaporate in the air fell back down onto your contained area and was recirculated. Project size over time has grown. So you're looking at approximately a 30-acre temporary cover in this application. Again, this was a facility, wasn't sure if they were going to do final closure at this time or not, so they decided to go with a 40 mil LL membrane in expectations that they could possibly turn this into a final closure. One thing to note, the windscreen in this installation is only held down by the sandbag burrito termination. So the entire 30 acres is held down with a perimeter burrito wrap. Besides that, the only thing that's adding any kind of additional surcharge to the system would be this access road that you see going across the top. So definitely can get pretty creative in your termination and effective. This is kind of a new application for the windscreen system, first of its kind, but you're looking at a power plant application with a series of water processing ponds. Essentially what the initial design called for was 15 inches of riprap, your textile layer, a foot of cover, granular material, and another textile. This was all supposed to be placed on top of your base 60 mil membrane as a means for ballast and UV protection. So the client approached us and asked, is there another way we can ballast the slopes of our pond and provide the required UV protection? We came up with a design which utilized a 24 mil reinforced membrane and the knitted windscreen on top. So the anchor trench was utilized at the top of the slope, but we needed a way to terminate at the toe of slope. So the base 60 mil liner would receive a cap strip, essentially about 2 foot wide strip. A 30 mil would be extrusion welded to that strip, and then those materials would all be sewn together to that 30 mil flat. So here's a photo of the installation of the toe of slope termination. So when the installation company first got out on site, they were cutting all of these strips by hand and installing everything, essentially fabricating this on site. This same design was implemented on another 3 or 4 facilities, and from the time of the first installation, now all of these cap strip details have been prefabricated in a factory and shipped directly to the job site. So definitely saving some time on extrusion, welding, and cutting, and dealing with that in the field. Saved a lot of time. So there's just your after photo. Your primary basins and holding basins they received some concrete on the floor, so the windscreen system did not extend across the floor, but the secondary basin was approximately 500,000 square feet in size, used that windscreen system not only on the slopes, but across the floor. So as I said, installations with the windscreen system have been growing in popularity and in size. So the largest to date is a 3.8 million square foot installation, still under construction. But this is a great photo to show you the difference in the color of the material. So as I said before, if you don't keep the same side facing up consistently throughout the installation, you will see some color change. So, you can see the tan green side of the system versus, your green side of the system. Definitely something to keep in mind for aesthetic value. So in conclusion, I think the industry is definitely moving towards the use of exposed membrane cover systems more and more frequently. These cover systems provide a lot of benefits to the landfills, to the clients, to the owners, and I think it's really important that we all try and keep safety in mind, analyze the use of prefabricated membranes. They might not make sense in every application, but for steep installations or areas that are very difficult to get in and maneuver, prefabrication could be a great option. So when you're looking at ballasting these applications, keep in mind, your maintenance, your life expectancy, and the other factors when you're choosing which ballast system is the best fit for your application. And if anybody has any questions, feel free to reach out to me via email. Tim, I believe, is taking over at this time.
Okay, great. Thanks, Elliot. And that's correct. You can contact Elliot here with this information, or myself, or Jen Miller, who's the coordinator of the Fabricated Geomembrane Institute. So Elliot, if you advance the next slide. So our October webinar is lightweight aggregates for civil engineering applications, and Archie Philshill will be our speaker there. And the last slide before I go to questions is, Elliot, okay, is please check out the FGI's website. There's a lot of information there. One interesting new feature is the online PDH program. So if you need PDH credits, you can watch some of our prior 14 webinars and watch the webinar, and then the system will send you a PDH letter for watching that webinar. Specifications, guidelines are there, detailed drawings, technical papers, videos on ASTM laboratory and field test methods if you're interested in performing some geosynthetics testing. Okay, so thank you, Elliot. I have a bunch of questions here. I'm going to start at the top. How about a deer walking on it and damaging the material? Is that a possibility with the knitted geotextile?
Yeah, that definitely is a possibility. We've seen it on several facilities. I guess one thing I didn't mention with the windscreen systems, the way that the filaments are knitted together, it provides a lock stitch. So any holes that are created in the system won't propagate. They won't have that zippering effect. They will be contained to the hole size that they are initially. Small holes in the system haven't, been an issue in terms of performance, but they can be repaired very easily. Essentially, what you would do would just cut out a larger hole in that area, large enough to actually install a patch and sew in a patch into that hole.
Okay, and that's is that hand sewn or like the seaming or sewing device that you showed in one of the slides?
Yeah, it would be with the handheld sewing machine that was in my previous slide.
Yeah, okay. Okay, next, actually, there are a couple of questions. Can I get the slides in a PDF to my personal email? The answer is yes, if you send Jen Miller a email message so she knows who to send it to. Otherwise, the PDF and the video will be on the FGI website. Next up is, how does the knitted HDPE geotextile perform compared to typical geotextiles in minimizing thermal expansion and cooling of the underlying geomembrane? In other words, could you order a heavy enough non-woven geotextile to not only UV protect the underlying geomembrane, but also provide this slope protection?
So what makes a knitted geotextile different, it is a HDPE textile, so it's UV stabilized. It's gonna not degrade over time. But I guess the main question is, what kind of UV protection would it provide in terms of cooling to the underlying membrane? The knitted windscreen textile is a 60% UV blocking system. So when it's used in conjunction with certain liner from certain manufacturers, it'll actually extend their manufacturer's warranty if the windscreen system is used over top. If in comparison to other traditional geotextiles, I think the big issue with the traditional geotextiles is going to be the lifespan and the quick UV degradation of those materials.
Yep. Next question is, have UV tests been conducted on the knitted geotextile, for example, xenon arc or fluorescent lamp? If so, what are the durations that the knitted geotextile has been able to undergo?
So we did accelerated UV testing for a period of 16 months. Essentially what they would do is every quarter cut a sample which was exposed to intense light, moisture, simulating Arizona's climate, and then the values from that were then extrapolated and produced the curve, which would show you the expected lifespan of the material. So our tests that we've done so far show a 55-year half-life and a 90-year expected service life to our system.
Okay, 55 years. So this is my question, Elliot. So is there a warranty then? Is it 55 years or on just UV, not physical damage?
Right. So the warranty that we offer is a 10-year exposed warranty.
Okay. All right, good. Next is, okay. So this is a installer of geosynthetics. We see a lot of ballast designs and they often seem excessive. What design parameters can you recommend, Elliot, that they can suggest to either the engineer or the QC people such that the ballast is reasonable tubes or reasonable sandbags or some other ballast option? What would be sort of reasonable parameters?
So parameters, I guess, with the traditional rope and sandbag systems, I guess reasonable parameters, I would say many of the installations and the specifications that I see often default to a typical 10 by 10 or 5 by 10 rope and sandbag grid. I've had a few engineers actually do wind uplift calculations for me to review, just to see how that calculation is done, how they analyze, how they make their assumptions. And I think a lot of times when those when you run the numbers, it actually comes out with a more frequently spaced sandbag deployment. So, every 2 to 3 feet. And I think, some assumptions are made just for the sake of, I guess, what's practical in the field. So I hope I'm answering the question and what design parameters. I'm not sure I know how to answer that question any better.
Okay. But that gave me an idea, Elliot. If you have done some typical calculations, maybe you and I can work together to put like a 1 or 2 page calculation sheet on the FGI website, and then people could take their wind speed and their slope angle and so on and plug it in and see what they get. So sure. Let's work on that. Second is, you said a 5 by 5 layout. So what does that mean? That would be 5 feet down slope of the prior bag and then 5 feet over, or what's 5 by 5?
Yeah, so it's either most of the traditional rope and sandbag systems are 5 by 10 or 10 by 10. So essentially just means one sandbag if it's a 10 by 10, every 100 square feet. So every 100 square feet, there's a sandbag. And if it's a 5 by 10, every 50 square feet, there's a sandbag. They can be spaced differently. Some engineering folks like to have rope lines both vertically and horizontally on every bag. Others will take a less frequency in the rope lines when it's running horizontally, because those horizontal rope lines are really in place to stop the vertical rope lines from shifting side to side.
Yep. Okay, here's another one. Yeah, so actually this gets to what I just talked about. Do you have a recommended calculation method to determine the wind load? So maybe this is a second question along there, so maybe we should produce some calculation pages. But how do you estimate wind loads?
The engineering community is who is really doing the estimating on the wind loads. They typically use J.P. Giroud's methods for determining uplift forces and how to counteract those forces.
Okay. And actually, well, Elliot, that'd be great. If you know that paper, I'll get a PDF of it, and we'll add it to our website where the video will be housed so people can download the design method. But again,
Okay.
It might need to put some sample counts up. Let me see. There's I think okay. When using HDPE, and I don't know what that means, whether it's for the protection or actually the geomembrane, what determines the material you use for the ballast system or weight system? We sometimes use a tube instead of the traditional sandbag.
Mm-hmm. I really think that comes down to the owner's or engineer's preference. I see a lot of sand tubes utilized in a lot of basin applications. So I really believe it just comes down to the desire of your client and your engineer. But in my experience, I've seen a lot more sand tubes and ballast tubes being used in basin or lagoon applications, and your rope and sandbag systems, windscreen systems are used a lot more in your sloped capping applications or cell rain cover applications.
Okay. Another question, have installers utilized a wedge welding machine for seaming the knitted geotextile instead of the sewing?
That's something that we've been experimenting with since we formed the company. We haven't been able to really come up with a solid way to wedge weld in the field. Just with the inconsistency, with the pores in the textile, it's really hard to get a solid weld on the material without weakening it too much. So we found up until this point, prayer seaming has been the most effective.
Okay. Another question, different question. Do you have any suggestions for providing access to gas extraction wells with the knitted geotextile, especially on steep slopes?
Yeah, that's been a common question, I guess. Is the short answer is we've been experimenting with some different products. Currently using a treadway product, which is made out of PVC, that we are doing some experiments right now. We just installed on a facility 2 weeks ago. So we're going to get some feedback from that facility to see how it's working and how it's performing. I know the windscreen systems and the liner systems are pretty slick to walk on side slopes, right. Especially with any condensation. It's definitely going to be very slippery. So hopefully this system that we installed does help. I think no matter what, with condensation or dust, and I'm not sure if there is a foolproof answer out there to reduce the amount of slips and on site.
Yep, exactly. Another question related to landfill gas. How do you recommend managing landfill gas pressures under the geomembrane? So on the underside of the geomembrane with the either sand ballast or windscreen on the top of the geomembrane?
Sure. So there's different techniques I've seen sites use, different things from pressure relief valves, which are actually built into your lining system itself, which can be set to, off gas at a certain amount of pressure buildup. Other methods have been using strips of composite. There's some other systems that I won't call by name, but they can also be installed underneath your lining system. Tubes can be connected to laterals at the top of the slope or headers, so vacuum could actually be drawn on the surface. So there's definitely a lot of different options to combat the surface gas and prevent that gas uplift.
Okay. Let's see. HPE, we sort of had one like that already. All right. I think I've covered most of them, Elliot. So anything you want to wrap up with at this point?
No, I appreciate everybody's time. I know I went through a little quick there, but if there's anything I can do, feel free to send me an email, give me a call. I'm on LinkedIn and you can get all my contact information there as well. But yeah, I appreciate everyone's time.
Great. So before we end, I want to encourage everyone to visit the FGI and the IGS North America websites. The FGI is on the screen. The IGS North America website, if you just Google IGS North America, it'll come up. And to learn more about these organizations and to consider joining and becoming involved in the geosynthetics industry. Thanks in advance for your interest in these groups and for attending today's webinar. So thanks again to Elliot Pugh for sharing his expertise with temporary geosynthetic covers. Thanks, and I hope we'll see you in October.
Great. Thank you, everyone.